So now I want to introduce Shri V.S. Vasudev. He is the Chief Designer, Structural Design, Hindustan Aeronautics Limited. And whatever he says are the fundamental aspects of design, which is required for all MSME or any work you want to do, these basic design aspects are very much required. Now I request Shri Vasudev to continue. Thank you, sir.
First of all, hearty welcome to this session. And before I start, I think it is a challenging session to engage an audience after lunch. I think I am also aware of that. So let me see how. So this session is more on how technology has really gone leaps and bounds. And especially the industries are also looking at aerospace because of the spurt in a lot of indigenous activity in the aerospace segment. So what I would like to do is, first of all, look at the trends. Before looking, I'll take a short introduction about HL and a couple of things about ARDC from where I come from, which is the Aircraft Research and Design Center. And Hindustan Aeronautics, actually now we have presence in all the whole gamut of aircraft design, rotorcraft design, manufacturing, equipments, and LRUs, and so on. So it is a whole gamut of things also into the aerospace segment for the aerospace structures and so on. And ARDC is a flagship design house for fixed-wing aircrafts, wherein we are basic designers of major projects in the country, starting from the earlier Kiran to now LCA, all variants like Air Force fighter, trainer, and naval variant, and also coming to the new LCA Mark 1A, which is an upgrade of the LCA Mark 1. And the now, and we are also looking at AMCA and other projects. So there is a lot of activity in the aerospace arena in the Indian segment, which I'll come to finally. Yeah. So ARDC is basically a design house which are looking at development of basic and advanced fighters and trainers. And the things we are looking at is system design, airframe design, testing. We are looking at ground, at wind tunnel aspects, and so again, it is a life cycle development, like concept to design to manufacturing, prototypes, productionizing it, and again looking at any issues over the life cycle of the aircraft. So this is about ARDC. Yeah. Now coming to, before I start, let me just what I will be covering here is what are the kind of drivers in the aerospace arena, which has driven a lot of development, and how major OEMs in the aerospace segment have adapted it. Now, basically, when the new projects, what we are going to handle in future also, requires a great deal of automation and precision and so on. So we'll also get a glimpse of what foreign OEMs are doing, and finally we can look at the Indian context. So just looking at the global situation now, the growth rate in the defense, the whole of defense is around 8%. And of course, what is driving this is again the digital technologies. Now, your Industry 4 is a great impetus which is given to A&D, the A&D segment, wherein there are a lot of new technologies which has been, and it has been leveraged very well, like the intelligence, the business intelligence has improved so that getting more revenues from that also. So I will just start with, it is kind of technical. I will try to give some insights where some specific manufacturing requirements are required in the industries. But definitely what you can take from this is the digital innovation spin-offs, whichever is there. I think that is very much important in today's business, and even in some of the technologies which we have incorporated. Okay, this is just a historical slide just to tell you how things have moved from basic loom weaving in the earlier days to how we had the initial assembly line of Ford and PLCs, and then finally the cyber physical systems. Like you are having a interaction of cyber and physical, so that this is one of the defining moments in networking and connectivity. Now, coming to Industry 4, I will talk to you a little bit about Industry 4 and give examples from the A&D industry, how it has been connected, how it has been leveraged. So there are a lot of things which you might all be knowing about the automotive industry and Industry 4, how it has been leveraged, but similarly, in what ways you get kind of benefits in the A&D industry, we'll just have a look. And basically, we all know Internet of Things, cloud, and other sensors. With sensors and embedded software are the key to these things. Yeah, coming to the technologies now, you have Internet of Things, cloud computing, additive manufacturing. You can talk in the manufacturing context or also in the Industry 4 context. AR is a very, very big tool. I think a lot of startups are also doing a lot of AR development. And I think this is one area. I will show you some movie clips also to just to understand what is the way it has been leveraged in the aerospace industry, so that you get the whole idea. Big data, again, big data is one of the most important data per se doesn't give you much because there's a lot of data, but how do you act on the data? What are the tools and what are the techniques you have to get something which is really useful to you? That is the main thing. Okay, coming to IoT. Now, IoT is again, your machines on the factory floor can talk to each other, but to make it talk to each other in a very useful way, you have to do a lot of things. And again, it is not only the machines on the factory floor, it is again the whole gamut of operations, like the supply chain. You have the supply chain management. Yeah, you go back. And also the aftermarket requirements. So you have to get back data from the use case scenarios and put it back and try to operate on the whole data. So it is to try to glean data out of the whole system in right from the concept to the usage. Yeah, next. Yeah, coming to cloud computing. See, for example, any startup or any small industry might not want to invest significantly in computing resources. See, basically computing resources can be leveraged from the cloud with the hosting companies. There are a lot of hosting companies which, because this is a very important thing, because you have a server at your disposal, you have software at your disposal, you have data generation and analytics at your disposal. So you can leverage the cloud. And also, for example, you have even today when you take a drone operator, a drone operator could be doing operating drones for many activities. For example, it could be deliveries, it could be agriculture, smart agriculture. Now everything needs to leverage data from somewhere. Now again, basically, the back end for the drone computing and, for example, your delivery drones would want scheduling, tasking, and the destination aspects to be given to it. And similarly, agriculture, smart agriculture, you have to upload a lot of sensor data into the cloud so that it can be operated upon. So this is a wide gamut of things which is there. And it is all improving collaboration, connectivity, and generating data. First thing it is generating data. Then we'll see how to operate on it. Yeah. Next. Yeah. AI, see, artificial intelligence and machine learning is a buzzword, but all this big data is of no use unless we have some kind of uh, cognitive intelligence. It has to work on that and try to get kind of useful information for you to act on. So that is very important. So it could be operational intelligence or it could be business intelligence. So either of that. So the main thing is we need to have different kinds of algorithms which will be built into the AI software. It could be learning algorithms, it could be neural nets, it could be something else. And there is a lot of pattern recognition algorithms which will really get the benefit for you. Next. Yeah. Okay, application. First I'll start with fuel efficiency because this is one thing just to give you a glimpse of how you can leverage the intelligence of the system. For example, you have a lot of operations, commercial operations, you have see, today's airline industry is really trying to save costs because otherwise it is not profitable. Now, how do you manage this kind of operations? You have any company would have invested in a fleet of aircrafts. Now, these aircrafts are going from different destinations, and the fuel consumption. You have a lot of data generated on fuel consumption. For example, you have a flight profile from point A to B. You are having a weather pattern. You are having a altitude in which you are flying. You have a air corridor in which you are flying, and you have a lot of things. You have a routine flight path. You have the same flights in different conditions. So there is a lot of data with a lot of sensors. You can download a lot of data after, if there are the requisite sensors in the aircraft, you can download, you can milk the data after landing, or even it could be sent. See, for example, a lot of engines even send data real time to the OEMs because they have to monitor certain aspects. So that means you get data, but now you can act on it. And second thing is these things, again with different weight combination, different payloads, different weight. Now if you can act, if you get all this data, now even in different segments, you can use this data. If you can keep on generating data like that, if you have a AI-based analytic tool, you can really find the optimum flight path for a particular thing, and also the payload what it needs to have. So it can get you revenues in terms of optimal fuel consumption based on operating of such data. That is one thing. See, improved, one more thing is very important is flight scheduling. See, flight scheduling today, because all your commercial airlines like SpiceJet or Indigo, see, basically you need to get the routes first. For getting the routes first, you need to know who is traveling where and what is the density of traffic. Now, based on the usage patterns and historical data, you can always try to see, it can predict, you have predicting ability of these softwares to say, this route would be profitable to fly, and you try to add one more route in this route so that you maximize your profits. So this is the way AI is in play to get you the best of economics in these things. And Okay, customer efficiency. Okay, I can today AI-based chat bots. We have a lot of things. Nobody is having the call center is the last resort because first your app will ask you to converse with a chat bot. So it will give you an option of what to do. So based on that, it will give you some other options. Finally, only the customer executive will answer to you. So things have changed. If you notice, nobody talks to you directly now in a call center. So that is through AI. They have leveraged that 60% of the chatting is not done with human intervention. So that is the leveraging of things. And okay, this is now, if you see again, in a aircraft industry, the part wear and tear and breakdowns and all, see, as a designer, what happens is, basically, you know the life of the component. When you design, you are looking at various aspects like you're looking at strength and other functional aspects. Other than that, there is a lifing of each component and other things. Some critical components also needs replacement. So these kind of things are also existing. Now, it is very important to monitor a lot of things. You have, with the present technologies, we need to employ that to ensure that you are forewarned in many cases so that you don't really wait for things to happen. So in that way, you can see what is the when is the next cycle of change due, or when there is a probability that the wear will be critical. So we'll have to act upon that. So this way you look at things, and with these technologies, it is all working on patterns of data. It uses historical data like mean time between failures and other maintenance data which you have. It is overall trying to operate on data to get you the best. So that is the main thing. Yeah, next. Yeah, this is one of the very important topics in aerospace context. See, there are two things in the industry today. One is digital twins in design, and one is digital twins in manufacturing and shop layouts and whatever. So basically, um, there are in design there are different simulation tools like model-based system design and engineering, where you can mathematically model a system. For example, a hydraulic system I can model. Yeah, I can model an electrical system, and they are all like building blocks. You model that, you connect to each other, and you can play with the connections. Play with connections means it is mathematically computed across the connections. So that means you can simulate before even design, you can simulate what to design. So this is a combination which works for me. So I would be looking at that. And if I could vary many parameters and variables and try to get the best of everything. So we do that a lot. And see, for example, to give you a simple example, you have an undercarriage system in an aircraft. The undercarriage system is now connected to a hydraulic system which actuates, and then the undercarriage opens up. And this is again signaled from the cockpit. So this is a simple scenario just to get the understanding. Now, when you can model the electrical part, you can model the hydraulic part, you can model the mechanical part. You can connect the simulations also, so that when I operate a switch, it is a signal. It is a voltage. Now, how it is operating, what hydraulic selector valve is opening, what is the rate of flow. So you can mathematically model and simulate and check. Suppose I reduce the pressure, will it still open or not? So these are the different kinds of combinations you can try out in a twin. A system twin it is. Like for example, hydraulics connection with a cockpit that is electrical and mechanical. So this is one. So if you can really do this with all systems in an aircraft, but it is a big deal. Like you will have to do a lot of connections, interconnections, and try to simulate that. Okay, now the other one is the aero engine. See, this is a video from your G, which Your engine has an exact replica of a digital model. It is a digital model is not a model for you to see the dimensions and that. It is a functional model, like the dynamics are simulated. Everything is simulated. Whatever is there, what data is there in the actual engine, the output of that can be fed into this. So what happens is, I have a sortie with the engine, the data is downloaded and fed to the digital twin. That means whatever that has experienced is also experienced in the digital twin. Now if I gather big data like this, if I am going to pull in data from the actual working engine to a digital model, and then I can do a lot of predictions. Your AI-based algorithms can predict what will happen to what all parts and what would be the, you will know a complete, your understanding would be very, very clear, and it could not vary too much in predictions, because what is happening, you're trying to feed it and trying to get the outcome. Yeah. There's a small clip on how GE has leveraged this, just a quick clip.
Electronic replica of that engine. Every single flight, sensors on the actual engine collect information about the engine's performance, and that data is downloaded either during flight or once the plane pulls up to the gate. A single flight to Europe is enough information to fill a computer's hard drive. It's then transmitted to the digital twin, or the electronic version of that engine, so it's always up to date with the actual engine in the field. GE Aviation Lafayette Executive Plant Leader Eric Madison says this allows GE to monitor remotely an engine's performance and predict things like maintenance issues, ultimately reducing costs long after the engine has left the plant.
Just what I said, it is just a summary of what I said. So the operational data is fed into the digital twin to make it more realistic, and it can simulate and predict many other scenarios in future. Yeah. Now coming to big data, again, there is the data generation is on a very, very large scale in any aerospace industry. And you'll have to look at what are the types of data, how do you federate this data to have a common, it should be acceptable in different forms. So that is one thing. And the reliability of the data is very important. How is it a data you want to process further, or do you want to leave this? You want to declutter the data, you need to do that. So you can't operate on you cannot operate on all noise around, so you just take what is required. So that is one thing, and how fast you can get the data to the decision making, or you get something out of it. So it is all about getting something out of it. So how quickly you can do it, and is it, sometimes you need it in real time, sometimes you can wait for some time, it depends on the context. So, and of course, the scale of data what is generated is very, very large, and we need to look at how quickly you can act and how what kind of AI techniques you want to use for that. Next. Yeah, this is what I was telling about predictive responses. You can get a lot of predictive responses based on the AI technologies, and to forecast it, forecast business and engineering decisions. And as it is written there, it predicts likely outcomes and appropriate response what you can do. So that means it is giving you something very specific. Either you can try this, or I try option 1 or 2. So that is what we need. We don't need a silo of data sitting in front of us. We don't know what to search in that. So you need some intelligence to give you something to act. That is the basic thing. Yeah. Next. Yeah, this is just to give you an idea of an aircraft project, just to tell you how data is generated. Now, if you are seeing, you have, let us take one aircraft project 1. It has design, it has manufacturing, it has assembly, flight operations, maintenance, testing. Testing is, it is physical testing on the ground. Now, the testing data is very much important for the design, because what was your assumptions, when the part failed, because you test it up to failure. So that is an important thing for design. Maintenance on the field, what are the problems which you have faced, what is the issues in the squadrons, all those data is maintenance data. So it could come back to one part or many parts or whatever part, you know where problems are there. And similarly, manufacturing, the deviations in manufacturing, deviations means suppose some parts repeatedly I have snags. It is only processing snags. So designers should look into that. Is it amenable for manufacturing, or do we have to do something more to get it aligned for manufacturability? That is also an important thing. So similarly, assembly deviations, have you given the proper tolerances, gaps to assemble? These are all the things. The historical data would point to you what we have to do. So that is the thing. So similarly, if you have so many projects, you get generation of big data across all life cycles. So this is huge data. But it is operatable data if you have some intelligence. This is how it is interconnected. So it gets a better design knowledge. The design knowledge can be extracted. And of course, you can optimize flight operation and other product design also from all this data. Okay, next. Yeah, now coming to augmented reality. See, augmented reality is one of the game changers what I've seen in maintenance especially. Because, and training. See, what has happened today is you have the physical world or you have a virtual world. You don't have something in between. In between means if there is a chance for me to overlay a virtual world on top of the actual world. So that is what exactly augmented reality is. For example, if you wear equipment which is connected to the CAD and other systems. Now what happens is the visualization of the person, as he is visualizing the physical parts, you can either give him some options and menu to find more information, or you can visually overlay certain things in the physical world. So this is a small, see for example, a person tightening the bolts in the engine bay, what is the torque value he requires? So instead of trying to refer to a drawing or a manual, it is, if you have a augmented intervention there, it is a very, very easy thing. And I'll just show you how Airbus has leveraged this. Just it will give you an insight of, here in the next video clip, you will be looking at how a designer is looking at the product in the shop floor along with augmented reality to find whether his part will assemble or not. Yeah.
The advantage of the Hollands too in the design process is mostly in the validation phase, where the designer needs to know whether his or her design is really fit for industrialization. And this is hugely accelerated by 80%. On the manufacturing side, we use Hollands too to enable the workers to achieve complex tasks or tasks that require an intense reading of documentation. Well, finally, they're hands-free and they can access complex areas, they can handle heavy parts while having all the information they need right in front of their eyes.
Yeah, you can see now if you look at the global manufacturing scenario, with these technologies, your drawings are a little bit outdated. So there are a lot of tools to overlay 3D graphical data on your physical workspace. So that is a huge difference. It makes a huge difference. And yeah, okay. Now this is one more thing. See, the other way of using AI, AR is like when a technician is trying to drill or trying to rivet or doing something there, the next instruction can be projected. For example, that hole can be highlighted where he has to drill or rivet. So the work instructions can be projected as well as the which hole he has to drill in that sequence. So it is all programmed. Now, see, there is a lot of leveraging here. You customize solutions to do these kind of things is going to help the industry. So the startups and other small industries who are into this field has a lot of opportunity in this area, wherein you can deliver customized solutions like maintainability solutions and also training solutions, because these are all, your virtual training would be as good as a physical training. Next. Yeah, coming to additive manufacturing, again, additive manufacturing is again a new technology wherein you are not, you are generally, traditionally, you are trying to remove material to make a part. Here you're trying to add material. By the look of it only, it means that you're not wasting much material. So basically, how do you do this? There are a lot of 3D printing potentials for the startups or industries which are looking at this as an option. Because I'll talk to you both about the good things and also the flip side of it, so that we can make a call on what is required. Now, basically, you can, in a prototype scenario, it is very, very useful because you can't invest on big tooling and other things, and so there it is very useful. And second thing is the reduction of cost and time is also there. In some processes can be a little costly. Yeah, okay, next. Yeah, how does it do this? Now, basically, there are many methods of doing this, but you have a CAD-based model. With the CAD-based model, you have slices of the model. It is a slice of data. This data is again processed. The sliced layers are processed by a system. Now, this additive manufacturing systems can use many techniques. One of the techniques is called laser sintering. What it does is, from a base plate, from the base starting point, it builds the material upwards, where the materials are melted and fused. And after you finish each and every layer, now you might be doing, in some systems, you might be doing thermal stress relieving and other operations before the final finishing. So it depends on the context of what parts you're producing. But there are certain parts which are complex, better to go for this. But yeah, next. Many aircraft manufacturers have done some of the components with 3D printing. But one thing I would like to say, see, basically you have a metal matrix powder which is used here. And once you get the part, the strength might not be as equivalent as the aluminum alloys which you use. You need to be a little careful. You have to do some kind of testing and generate data so that you are well informed before you take a decision. So now even that is being evolved. You are getting a lot of good material matrix which can be used for this, and that is okay. Yeah, next. Yeah, this is a small clip.
Done at the Department of Energy's Oak Ridge National Laboratory, saving energy, time, labor, and production costs.
One of the obstacles that we had to overcome was the pure size. So when you're looking at laying down layers of material to build the additive component, there's a certain amount of time that you have to go back over the top of a previous layer.
Yeah, just I think I'm running short of time. We will just quickly rush through certain things. I think these are all the fighter aircraft evolution and based on configuration enhancements, technologies and weapons integration. Yeah, next. I'll just run quickly. Commercial aircraft, again, you know the story. I think I will skip this. And drones, of course, you have a lot of applications in inspection, terrain mapping, inspection of power lines or perimeter fences. So these are all the things which I think it is quite popular and is known. Yeah. Next. Yeah, military aviation scenarios, again, have seen all these kind of evolution technologies which has come in. And the current technology which is the UAVs for teaming. This is, we are trying to, even HAL is trying to do a CATS teaming system with a different kind of, it is having a UAV concept. So you have a swarm of UAVs, you have a mothership, you have a pseudo satellite which gives you information and so on. This is a new trend in warfare. Yeah. Next. Yeah, this is the evolution in space technology. Now there has been a lot of startups in the cargo delivery to spaces in the recent past. Yeah. Next. Yeah, aviation technologies. Now, here I would like to just spend a couple of minutes. We are dealing with a lot of composite structures in today's designs. Uh, there is a potential for thermoplastics also, nano and stealth materials in all. See, the new projects like AMCA, which is a 5th generation, stealth is a driver. So the processing of such technologies is also required from the industry point of view also. But this has to be evolved from the OEMs and given that is there. So there are a lot of labs working on all those things. So next, yeah. And shape memory alloys finds application in many of these aspects. Yeah. Next. Now sensors is very important because your fly-by-wire system of today is all about sensor interplay with the flight computers. For example, if you look at air data sensors, it is very critical to flight because flight control is by control law, which is processed in a flight computer. Now, the main thing is if your sensor gives wrong data, then you have a lot of, it is catastrophic. So we have to have redundancy, we have to do a lot of other things. Yeah, I'll just skip this. Yeah, radars, again, radars also, we have a lot of evolution. Today we are looking at ESA radar, which can process multiple targets, it can recognize, process, and give a feed to the central computer for targeting. Yeah. So the technologies have changed from the mechanical controls to fly-by-wire. Light is nothing but optic fibers. So this is about the control technology. Yeah. Next. Yeah, this is the weapons also has been from conventional to smart to laser weapons in the aircraft today. Yeah, this also has seen a great change. I don't want to spend much time on this. Yeah. Yeah, this is, see, basically, we have progressed a lot from basic CAD/CAM, PLM, MBD, and MBD is today we are doing designs with MBD, which is model-based design, so that you don't have a drawing. You have dimensional data embedded into the model itself, which you can rotate, you can take section, you can measure, so that it is a better interface for manufacturer. And you'll get a 3D PDF file to use it. You don't have a drawing sheet. So these are latest trends. Even the design houses are aligning to such trends now. So what is it? Yeah. Now, just I wanted to say, because there are different, this one I'll skip the videos because this is for fast machining rates, and with cryogenic machining you can really save on tool life to machining speed, you can increase and so on. Yeah, next. And incremental sheet forming, again, this is also a new technology which uses CNC control to incrementally form with a snub nose tool. So that is the thing. Yeah. And this is one important thing which I want to tell. See, basically you are doing composite with hand layup. You have a master tool, you have prepregs which are laid manually. So a lot of problems in the quality when you do a manual layup. Today you have tape laying machines, you have automated tape laying machines. I could have played the video, but because of time, only one final video I want to play so that will give you an overview of the whole industry, so that you will know what I'm talking. Yeah, next. These are also robotic machining, because somebody asked me before the thing about in situ machining. There are a lot of requirements on the jigs to do some machining, local drilling and other operations. These are all required in the industry today, because the tooling in the next generation of aircraft, if you're designing, is all with a little semi-automated tooling requirements, and which will, because it is required. See, basically, I'll just tell you one thing which needs to be remembered. Like, for example, the contoured parts of aerospace. The tolerances on these contours are very, very important because we need precision there. Why I'm telling you this is a shape on the aircraft skin, let us say. It is arrived, it is a mathematical shape. In a fighter aircraft, it is more mathematical than geometric. So in a commercial, it is more geometric. Now, mathematical shapes, it is of many iterations so that your aerodynamics and the performance is hinged on that shape. Now, when a designer demands precision, when I say I need 0.1 mm here, if I say that, it means if you dilute that, you'll be diluting the performance. So that is the very, see why precision machining and this one is required, is because it drives performance to a large extent. So that is the, yeah, this is other things. Now, carbon foam based toolings for composites. It is still in development stage, but it is also a technological advance. Yeah, you can go. And reconfigurable part tooling, you have pogo machines, you have the individual pogo sticks which you can raise up so that you can preheat and then form the shapes. Yeah, I am short of time. I am not showing you a lot of videos because this is a sensor. For example, you want to do blind drilling. You can have a electromagnetic bush attachment at the back and then drill through it without having any problems. You have 2-3 parts, and I have to drill from back. If you have a situation like that, then you can use this technology to do that. Yeah, these are all assembly tools which are very flexible assembly tools. And jigless manufacturing is, jigless tooling is one thing. Jigless means it is not without jigs, it is less of jigs. Now, in this, the primary thing is the design is slightly reconfigured to provision this so that you have different kind of holes like mating holes, starter holes or coordinate holes to match between parts. And in this situation, we need precision NC drilling of even sheet metal parts because these are very, very precision holes which we need to mate in the assembly. Yeah, you can go forward. Yeah, these are all different automation scenarios in aerospace. I will just show you one final this one. So you can just, yeah. Now this, and today's design is more, this is a F-35 center fuselage. Today's design is more about modular design where even producibility is with modules. Modules means it has airframe modules and it has system bracketry, it has the system elements also into the module which is coupled finally. So this is the trend and this is how the aviation is going to be shaped up in the future also here. Yeah, you can go forward. Yeah, this is about jigless which I talked around. Yeah. Next. Yeah, metrology. Yeah, the metrology is one important area because we have come a long way in metrology from measurement to fixtures to checkout fixtures and now to part scanners and CMM. Now, CMM, you all know, part scanners is very, very important in today's industry because especially contour data processing and deviation measurement is a very important thing, especially in aerospace, where you need to ensure that the deviation falls within limits. You don't need to do manually, you just scan. Even today's iPhone 13 has a LiDAR sensor which you can scan any part also and you can process with the tools. Similarly, these scanners gets a 3D surface data of the outer profile so that you can compare with your CAD data and find out what is the deviation. It is hands off totally. can get a PDF report of the deviation. Next. Yeah. Yeah, okay. No, these are all different other aspects. I'll just, you just see the slide, I'll just rush through. Next. Health monitoring solutions, because you can, in flight, in real time, try to measure things. You can predict cracks, you can predict all those things by using various kinds of sensors. Next. Next. Yeah, this is our testing. I will not take much time on this. You can go forward. So this all involves a lot of big data generation. So it will be useful in the design phase finally. Yeah, this is one video I want to show. It is a 5-minute video which covers whatever I said. So whatever I have talked till today, this is how Airbus has reinvented itself with all the Industry 4 elements. So this will give you an idea of what things are to come in the aerospace industry, wherein everybody has to align to certain technology developments to achieve the goals of new products and projects which demand such things. This is a brief overview of whatever I did. Just go to the last slide, okay? Just last slide. No, basically, what I would like to say is the next generation requirements in aerospace and defense. You have a lot of technologies which have driven this to this stage, and it can be leveraged to get better products. And the demands of the products are such that we have to use technologies. So this was a brief glimpse of that. So now in the Indian context also, we have kind of new projects which are coming up, and the push for Atmanirbhar Bharat, and we are doing a lot of indigenous development. And with this, I think there will be a lot of growth in the small scale and MSME and startups, because technology driven startups are many in this country, and I think it is a very, very good opportunity to leverage the this one, because it is going to be a lot of projects, lot of products coming together at the same time, and the technology readiness levels also has to be matched on par with the automobile industry, which is kind of fully developed to a large extent. Now, aerospace also we have to work in that this one, and I think it is with the new projects that ecosystem will definitely be coming up, and it is poised for growth. Aerospace and defense in India is poised for growth, and there will be a lot of opportunities downstream to everybody. So thank you very much. It's a very brief session.
Any one or two questions we can take? Anybody has any question? Or during tea time we can interact. I think we compliment Mr. Vasudev for explaining simple terms what is Industry 4.0, what is AI and ML doing in aircraft industry, and which is required for even our MSME also in the days to come. And more than that, he showed the vision of a factory building aircrafts. I think building civilian aircraft is the goal of many of engineers like us. Civilian aircraft, we have not come to that stage yet. Maybe there are a few people trying out, but still it has not come to the reality. There are many, Gensar is there, Mahindra is there. They have all started trying to build a civilian aircraft. That is the basic thing for any engineer to tell that we have built a civilian aircraft. I think I request all of you to give a big hand to Mr. Vasudev for his wonderful presentation.